Have you ever stopped to think about how a tiny little ant and, say, a giant whale could possibly be connected? Well, today we're going to pull back the curtain and uncover this incredible hidden web that links every single living thing on our planet. This is the story of ecosystems. You know, this single idea right here, it's the key to everything we're about to explore. From the smallest microbe you can't even see, all the way up to the tallest tree, everything is part of this vast, interconnected network. And once you really get that, you start to understand life itself. All right, so here's our game plan for this expedition. We're going to start with the big idea, the web of life. Then we'll take a quick tour of different ecosystems around the globe. After that, we'll break down their building blocks. And finally, we'll follow the energy that powers the whole shebang. Trust me, by the end of this, you'll see the world around you in a whole new light. Okay, first up, we are digging into the single most important rule in all of nature. This is the secret that explains how everything from a single drop of rain to a soaring eagle fits together perfectly. So let's just kick things off with the most fundamental question of all. At the very heart of it, what's the one concept, the one idea that explains how everything in the natural world actually works together? And the answer is a single, powerful word: interdependence. It's the simple but really profound idea that nothing survives in isolation, not a thing. Every single organism relies on other organisms and on the non-living world around it just to exist. This is the master rule of nature. And the place where all of this interdependence happens? Well, we call that an ecosystem. You can kind of think of it like a neighborhood, where all the residents, both the living and the non-living things, are constantly interacting with each other. And we're going to break down those two parts, the biotic and the abiotic, very soon. So now that we've got that core idea of interdependence down, let's see it in action. We are heading out on a global tour to explore how this concept plays out in some of the most amazing environments on Earth, from rushing rivers to the frozen tundra. But hold on, before we dive into all these different places, let's do a quick recap. Can you remember the two fundamental parts that make up every single one of these wildly diverse ecosystems? That's right. It's the living organisms, the plants and the animals, and the non-living elements that they absolutely depend on, like water, soil, and air. Every ecosystem out there, it doesn't matter how different they seem, is built from these two core components. Now, this is where it gets really cool, seeing that diversity in action. I mean, think about it. In the fast-flowing water of a river, fish have to be incredibly strong swimmers just to stay put. High up on a mountain, animals need thick fur to survive that biting cold. And out in the huge, treeless tundra, life has to figure out how to thrive on permanently frozen ground. Each one is a totally unique stage where the drama of interdependence plays out. Okay, so we've seen the big picture of these different ecosystems. Now, let's zoom way in and put their components under a microscope. It's time to learn the official scientific names for the living and non-living parts that make up every single one. And that leads us to some key terminology. You are definitely going to see these words on your exam, so let's get them straight right now. What exactly is the scientific difference between these two types of elements? Honestly, it's pretty simple. Biotic means living. Just think of the word biology, right? The study of life. Abiotic means non-living. That little a at the beginning just means not, so not living. So plants, animals, fungi, they're all biotic. Air, water, soils, sunlight, that's all abiotic. The real magic of an ecosystem is how these two sides come together to create a world that actually works. Now, this might seem a little obvious, but it is such a critical connection to make. Why can't the abiotic things, the living things, just exist on their own? Why are these abiotic elements so absolutely essential for them? Well, this is a perfect example of that big word again: interdependence. Animals need air for the oxygen they breathe, no question. They need water to drink just to keep their bodies running. And they use things like soil, sand, and rocks to build their homes and find protection from predators. The living absolutely cannot survive without the non-living. It's that simple. All right, we've seen the building blocks of ecosystems, the living and the non-living. Now for our final section, we're going to do something really cool. We're going to follow the energy. This is the invisible force, the current, that connects every living thing in a vast, complex network of who eats whom. So the story of energy always begins here, with two main characters. On one side, you have producers. These are things like plants, and they're incredible.
They literally make their own food by capturing energy from the sun. Then you have the consumers, the animals, who can't do that. So they have to get their energy by eating other organisms.
But, consumer is a pretty broad category. We can break it down even further based on what's on the menu. Herbivores eat plants. Carnivores eat meat. And omnivores, well, they eat both. You've also got specialists like insectivores, and of course, the ecosystem's cleanup crew, the scavengers, who eat animals that are already dead. Okay, time for a classic exam question that trips a lot of people up. When you see a food chain, you see all those arrows connecting the different creatures. Which way are those arrows supposed to point?
Here's the absolute key thing you have to remember. The arrow doesn't mean eats. No, it shows the direction the energy is flowing. So the arrow always points from the organism that's being eaten to the organism that's doing the eating. The energy from the grass flows into the rabbit that eats it.
And we can organize these consumers into levels, kind of like a ladder. The primary consumer is the herbivore that eats the plant at the bottom. The secondary consumer eats that primary consumer. And then the tertiary consumer is often at the top, eating the secondary one. It's a ladder of energy, moving up from one level to the next. But here's the thing. In the real world, nature isn't some simple, straight line. Oh no, it's so much more complex and wonderfully messy than that. And that's what a food web shows us. It's like a giant, tangled map of how thousands of different food chains all link together, creating a true web of life.
And this brings us to our final and maybe the most important piece of this whole puzzle. We've talked about producers and consumers, but there's this hidden group, the decomposers, like bacteria and fungi. What do you think would happen if they all just vanished?
The answer is pretty dramatic. The entire cycle of life would just grind to a halt. All of the valuable nutrients in dead plants and animals would stay locked up inside them. The soil would become totally barren, new plants couldn't grow, and the entire food web would collapse from the bottom up. See, decomposers are the ultimate recyclers. They are the ones who unlock all those trapped nutrients from dead material and return them to the soil. That's what allows new plants to grow, which fuels the entire ecosystem all over again. They really are the unsung heroes who make sure the web of life can keep on going. So we've journeyed all the way through this incredible web of life, from the sun's energy down to the quiet work of decomposers. Which leads to one final thought for you. Which part of the web do you think is the most important? The producer, the consumer, the decomposer? The truth is, they all are. And that, right there, is the meaning of interdependence.